Welcome back. So in video 2, I showed you how to use the recursive formula. And I told you then that there were two different formulas we could use. So now we're going to get into that second formula. The second formula you're allowed to use is the explicit formula. This is also going to be found on your formula sheet. And it looks like this. Now, it looks more complicated, and it's true, it is a little bit more complicated. However, it's also infinitely more useful, because if I ask you to find a sub 25 or a sub 100, you do not want to sit and keep adding 3 100 times until you get to that 100th term. There's got to be a better way. So there is. It's called the explicit formula. So in this formula, a sub n is still your current term. So that's just your f of x. It's what are you looking for? A sub 1, remember, is your first term. So I'm looking for what's that very first value in the formula. And then n is going to be the index, meaning the term number. So you're going to plug in, if I'm looking for term number 100, then I'm going to plug in a 100 there. That oftentimes is going to be left in the formula because it's like your x. So we're used to dealing with equations that have both a y and an x in them. So this is going to be an equation that's going to basically be left with an a sub n and an n. And then the d is still your common difference. So it's what you're adding each time to move from one term to the next. All right, so let's go ahead and do this. We're going to write an explicit formula for this sequence, and then we're going to use it to find a sub 7 and a sub 20. So this is a sequence that we've seen before. We're adding 3 each time. But I'm going to write this explicit definition. So I'm going to plug in a value for a sub 1 and for the common difference. You'll notice that in the formula that's on your formula sheet, this common difference is written behind those parentheses. And then on this poster that Mr. Brock made, isn't it beautiful? He's so talented. It's on the other side. That's because we have the commutative property, and it doesn't matter which side you put your multiplication on. It's the same thing. So in this poster, everything that has boxes is going to get substituted in. So we know the first term in this. It's 3. It's the very first number in line. We also know the common difference. It just so happens to be 3 here as well. That's not always going to be the case, but it is for this one. So a sub n is equal to a sub 1 is 3 plus the common difference is 3, and then I've got n minus 1. The n is still going to be there. The a sub n is still going to be there. Now I can simplify this because we rarely leave things looking like this with distribution that needs to be done. So I'm going to distribute, and I get a sub n equals 3 plus 3n, because 3 times n is 3n, and then 3 times negative 1 is negative 3. And then I have some like terms that I can combine. 3 minus 3 is 0. So the explicit formula looks like this. Now I'm going to use that to find a sub 7 and a sub 20, like the problem asked me to do. And this is where the real magic happens. So up to this point you're thinking, man, that was so much more complicated than the recursive. But remember, to use the recursive to find a sub 7, we had to keep counting up and adding 3. And it would be really annoying to find a sub 20 that way. For the explicit, though, all I have to do is plug in the index or the term number that I'm looking for. So if I want a sub 7, then I'm going to go and in place of n, I'm going to put a 7. Just like when I want to find f of 2 instead of f of x, I just plug in 2's for my x's. So then a sub 7 is equal to 21. Which, if you go back to example 2 in the previous video, you'll see that we used this exact same sequence and found, using the recursive formula, that a sub 7 is equal to 21. So they both work, and they both have their uses. If I was just looking for the 7th term in this, I probably would use the recursive. I'd just jump up a couple more steps and get my a sub 7. But if I want a sub 20, I don't want to add 3 20 times. I don't want to write a sub 1, a sub 2, a sub 3, all the way up to a sub 20. So I'm going to use this explicit formula for that. So to do that, I'm going to use, again, a sub n equals 3n. So to find a sub 20, I'm going to put a sub 20 equals 3, and I'm replacing my n with 20. I just get to substitute it in. So then 3 times 20 is 60. So that means the 20th term in this sequence, if I were to continue jumping up, would be 60. All right, you guys go ahead and try a couple. Hopefully you'll see the usefulness of the explicit formula to find both the 7th term and the 20th term. Be sure to check your answers, and I'll see you on the other side.